Let us prove another theorem, and it is about the condition of integrability. It gives an important relation between integrability of the function and upper sum and lower sum. A necessary and sufficient condition for the integrability of a bounded function f is that to every epsilon greater than 0 there corresponds delta greater than 0 such that for every partition p of closed interval a comma b with norm mu of p less than delta, upper sum minus lower sum is less than epsilon. So the necessary condition, first we consider necessary condition. In the necessary condition we assume that the function is integrable. If f is integrable, and we know that we say that the function is integrable by definition of Riemann integration whenever upper integral equal to lower integral, then the function is said to be integrable and the value of that integration is equal to the equal value integration a to b. By Darboux theorem we know that the Darboux theorem says us that for every epsilon greater than 0, if function is bounded, there exists a delta greater than 0 such that with this norm mu of p less than delta such that the upper sum is less than upper integral plus epsilon. Here we take 1 by 2 epsilon, and the lower integral is greater than lower sum is greater than lower integral minus 1 by 2 epsilon. Now if we multiply equation 2 by minus, the inequality becomes less greater than to less than, and we have LPF is less than lower integral minus become plus 1 by 2 epsilon. Now let us add this equation number 1 and 3. If we add 1 and 3, we have upper sum minus lower sum is less than upper integral f dx minus lower integral of f plus 1 by 2 epsilon plus 1 by 2 epsilon. But friend, we have considered upper integral equal to lower integral, and therefore this value is 0, and we arrive directly at the statement upper sum minus lower sum is less than epsilon. So this is an sufficient condition. Let us take a necessary condition. In the necessary condition we assume that upper sum minus lower sum is less than epsilon. Upper sum minus lower sum is less than epsilon. Now by definition of upper integral and lower integral, we know that the relation between upper integral lower sum is less than equal to lower integral, and lower integral is less than equal to upper integral, and upper integral is less than equal to upper sum. Subtracting these two, this is like 2 is less than 5 is less than 7 is less than 10, but 7 minus 5 is less than 10 minus 2. So apply the same criteria here. The upper integral a to b minus lower integral of f is less than equal to upper sum minus lower sum, but upper sum minus lower sum is less than epsilon. Therefore we get upper sum minus lower sum is less than epsilon. Okay, but epsilon is an arbitrary number. Epsilon is arbitrary, greater than 0, whatever may be number. So there is only one possibility remain to us, this must be equal to 0, upper integral minus lower integral must be equal to 0. Since this number, this subtraction is less than any number greater than 0, and the number which is less than any number is 0. Okay, therefore this value equal to 0, and we have upper integral equal to lower integral. If upper integral equal to lower integral, then we arrive at the function is integrable function. So we have proved that whenever the function is an integrable, we get upper sum minus lower sum is less than epsilon. Later on we have, when we have taken upper sum minus lower sum is less than epsilon, we have proved that the function is integrable function. So friend, this is about the condition of integrability of a